Hi there, I'm the mechanic on Rogue. Today, I'm going to be talking about magnesium dioxide and its use as a catalyst in aluminum air batteries. Now, I know that there are some videos out there that have already gotten to the subject. However, this material is claimed to substantially boost the output of the aluminum air battery, so I wanted to share my experience with it. Manganese dioxide is a natural oxidant and is used primarily in the production of dry cell batteries. The method of application for aluminum air batteries is to react the carbon cathode with a solution of water and potassium permanganate, which has manganese dioxide in it. I'm going to give this method a try. In addition, I'm going to try an alternate method where I use the manganese dioxide out of a spent dry cell battery. Let's get started. The source of carbon that I'm using is 1mm graphite sheet. For my preparation using potassium permanganate, I put it, along with water and a couple pieces of graphite sheet, into a pot. Using my kitchen stove, I maintained a temperature between 70 and 100 degrees Celsius, and I manually stirred the mixture for 1 hour. If that sounds tedious to you, I can assure you in every way that it was. But I persevered in the name of science. As I understand it, the reaction that is occurring here is the permanganate is reacting with the graphite sheet and depositing nanoparticles of manganese dioxide onto the graphite. When the reaction is over, the solution is supposed to run clear. I didn't get to that point. After 1 hour, I ran out of time and called it quits. I rinsed off the graphite sheets and left them to dry. I do believe something was happening because the sheets, the pot, and the stir stick was covered in a brown residual substance that can be scraped off. For my alternate method, using a spent AA battery, I cut it apart and scraped some of the manganese dioxide into a beaker. I then mixed in some rubbing alcohol to make a solution, and after applying the solution to the graphite sheet, I burnt off the alcohol. This was the same method I used when testing the catalyzing ability of titanium dioxide in another video. I wanted to try this method because I heard that if the manganese dioxide particle size is greater than nanoparticles, it doesn't work. So obviously, I wanted to test that out. Now that I have my treated graphite sheet, it's time to move on to some tests. I'll be using saltwater as the electrolyte, and as with previous videos, I'll create a baseline first. With nothing changed, I've got 0.85 volts and 11 to 6 milliamps. Moving on to my treated graphite sheets, I'm going to start with the graphite sheet treated with manganese dioxide from a dead battery. Voltage is the same at 0.8 volts, and there's a minor increase in amperage, with the high being 30 amps before it settles down to around 12 milliamps. Nothing special, but this was the one most likely to fail. Onto my next sheet, which has been treated with potassium permanganate, and already I see an improvement. Voltage is 1.2 volts, which is higher than original, and here's the good part. I actually maxed out my milliamp reading on my multimeter, so what you're seeing here is my reading in amps. The high was 115 milliamps, with it settling down to around 50 milliamps. That's an insane improvement. Clearly, manganese dioxide makes a difference in the battery performance, but I had one further question. Does it work with titanium dioxide? As some of you know, I've already released a video where I demonstrated titanium dioxide improving the function of an aluminum air battery. Mind you, the improvement was minor, but it would be cool if both effects could be combined. Unfortunately, it doesn't seem to help, and actually negates the effect of the manganese dioxide. Well, I guess that's my answer. Just not the way I wanted it to be answered. To wrap things up, this turned out quite well, and I learned a ton of new information. I could definitely improve my process with the right tools, like a hot plate with a magnetic stir. But even manually treating the graphite sheet with potassium permanganate produced excellent results, increasing the amperage output by up to 5 times. By this measure, titanium dioxide and the larger manganese dioxide particles performed quite poorly, but they still gave a degree of improvement over my baseline readings. So that brings me to the end of my experiment for today. Thank you all for watching. As always, be sure to leave a comment and a like, and for more content like this, don't forget to subscribe. I'll see you on the next one. MGR signing out.